Today we are looking at Amazon Bedrock, and as you can see, this is the heart and soul of building generative AI applications and agents inside AWS. And Amazon Bedrock, it's a fully managed service by AWS, which they offer for um, basically working with foundation models. Like we'll see a couple of examples of what all has been exposed as the foundation models in AWS. And this is particularly different from SageMaker AI, because in SageMaker AI that we will see, um, the internal wiring of the models and everything, we need to have a bit of more control on the model deployments and all those things. In Bedrock we get these APIs, pre-built models, and we just need to plug and play certain things. So it's a bit of an abstraction, but yeah, it's better for actually someone who is trying to use these foundation models and not trying to build them from scratch. So if we go to the AWS console and we reach a Amazon Bedrock, we can see this is the landing page, and here it says there are more than 100 foundation models, and you can see some the famous ones like the Quen models family has been exposed here. These are from Alibaba Cloud. Then we have OpenAI, GPT, OSS. So these are not particularly the OpenAI ones, but these are the ones which the OpenAI has open sourced actually, and these are available for the general public. Anyone can actually host them. Claude by Anthropic. So these are actually by the Anthropic team. So all the Claude models are available. These are not open source. Then we have Amazon's Nova. So these are proprietary Amazon's models of the Nova family. These are again closed source. So similarly, we have Meta's Llama, which are again open source. So what Amazon has actually done is, so AWS has actually moved all the open source models and integrated them along with certain proprietary models as well. And we would see all the functionalities one by one that are available inside AWS Bedrock. And I think this would be one of the most important topics even for the certification that we are going to attempt. So let's first come to model catalog. This model catalog actually tells us, what are all the different models. As we saw, there are nearly 100 plus models. So you can see 252 models as of now. And Spotlight models is Nova multi-model embeddings. So there are a lot of variety of models that are present here, and each model is for a particular purpose as well. As you would see, it says, so this is the newest one, Claude Opus 4.5. So this is for hybrid reasoning, extended thinking, efficient code generation. So this means it is a model which is having a lot of parameters. So it's a huge model because it's one of the most intelligent ones, as Anthropic is kind of telling, and it's actually doing a lot of different stuff, you can see. So it's very efficient in terms of the stuff that it's doing: hybrid reasoning, extended thinking. So these are large models which actually go into extended thinking. All of this I think we'll see afterwards. And an important aspect of the exam also remains that, what model to choose in which particular scenario. So that's also what we'll be covering. The max tokens is 200k. These are the languages that it supports. And pricing, so this is the important part. For each model we have certain pricing. So the choice of the foundation model depends on two things. One is the use case that we are trying to solve, and the second is the pricing, so how much we are willing to spend. So if we go into the pricing, you would see, let's go to Anthropic. Okay, this is the region for now, Opus 4.5. For 1000 input tokens we have around $0.005, and this is the output tokens. For batch we have a slightly lesser cost, and this is for the caching. This also we'll see afterwards. So as you can see, we can compare different models. So this Opus 4.5, if you see, this is on the higher side. So as compared to Haiku or Sonnet, this is a bit on the higher side. And why? Because this is a model that has been enabled with extensive thinking. So it has the capability to solve complex questions or complex queries, as compared to Haiku or Sonnet. Haiku is the cheapest one, as you can see here, because it is not built for solving very complex kind of tasks. So it is built for simpler tasks, but it would be faster, it would be cheaper. And here we are in Haiku 4.5. You can see again it supports all this, it also supports these things, but again this is a smaller model, as you would see, as compared to Opus or as compared to Sonnet. So we should know, which model to use for which scenario. They also have code examples, inference parameter responses, but I think um, we are very much aware for what kind of use cases it will be able to solve. We would see that as well when we would play with these models. Then coming back to the model catalog, we also have these models by Nova. So Amazon is actually themselves build these models. You would see Nova Premier. So this is one of the, I think the one on the expensive side. And again for the complex one, then Sonic is for speech to speech. So you can see there are a variety of different models. If I want to actually have live speech analysis or live speech interaction, like building a customer care bot for which actually interacts in real time in speech. So for that we would use Sonic. We would also see an example of using this model. Canvas is for image to image. You give the model an image, it would return an image. You give the model some audio, it would return an audio. And here Premiere, Nova Lite, these are chat optimized. So these would expect text and they would return text. Now earlier what used to happen, we used to have these models, textual models, and on top of these textual models we used to have services like transcribe, so that would convert speech to text, and then again we would use poly or something like that to convert text to speech. So now instead of that, what the industry is using is these kind of models, speech to speech or image to image, so that the model is adept in actually conversing real time and there's very less latency as compared to those previous solutions. Now the pricing of Nova models, as you would see for Anthropic, we compare, let's go to Amazon. You can see these are a bit more cheaper. So because AWS is themselves offering them, so they have kind of trying to persuade people to move to their models, and that's the reason I think they have kept the prices cheaper than Anthropic that you would see. Even for Nivea, this Nova Premier, then Nova Pro is also good. This is comparable to Sonic that we see. Light is a smaller one, like we have Haiku, and comparable to the performance. And we also have Amazon Titan models. So these are text embedding models. So what they do is they convert your text into embeddings. Now what are embeddings and what all happens inside embeddings? We would see this with certain examples when we would go into the coding stuff and get our hands dirty. But yeah, we should know that these kind of models also exist. Then we have Cohere, DeepSeek. You can see all the different pricings that are there. Mistral, OpenAI, and this is OpenAI OSS. So these are the open source ones, not the GPT-4o and all those models. So this was about the model catalog, and we have it segregated as per the providers, as per the modality. And modality, I told you, it expects text or it expects images or it expects speech. So accordingly we have the different models. Okay, now moving on to the chat or text playground. And let me just select the model quickly. Let's use Nova Pro. Now this is the playground, and what happens here, like we actually use Claude.ai or OpenAI, that GPT, chatgpt.com. Similarly we have this, and but the only difference is that other than this being a model that we are using, we also have certain knobs that are available for us, like the system prompt. So the system prompt actually helps us contextualize the entire conversation that we would be going to have with this model. And this is all behind the scenes happening when we are accessing chatgpt.com or claude.ai, and that's also evident with, I'll show you the actual system prompt that Claude uses, which they have exposed. So let's say Opus 4.5. So this is the entire It would be a very lengthy one because it is a complicated application which they are building. But as you can see, this is the contextualization that they are doing. So they are telling that here is some information. So first they tell about the Claude to the model. Okay, you should know what is actually Claude. Then they can that Claude can discuss any topic, but it adheres to child safety and other things. So all contextualization, what the model should respond, what it should not respond, all that is actually available for Claude, and that goes into the system prompt, so that accordingly the chat that is happening with Claude is contextualized. So here we can also do that. Let's say if I have not contextualized, so what would do it would do is I'll say hello. So it would say, okay, hello, I am here with whatever you might need. But if I give a system prompt, let's say you are an AI assistant for AWS, helping users queries for different services. Okay, now I have actually contextualized the model. Now when I'll say hello, so now it understands, okay, if you have any questions about the AWS services, no, this is not available to the end user when we would expose our models over the different services. So but the foundation model would actually be contextualized, and if we say don't respond in this way, respond in this way, you are restricted in this way, you should just need to do this XYZ. So all that can be actually mentioned inside the system prompt, so that the user is not able to actually influence the model or contextualize the model, but yeah, it can interact with how we have contextualized the model. Then we have the output tokens. So for understanding maximum output tokens, here we need to know what are tokens. So tokens are simply how the model sees words actually. Okay, so what happens is this is the tokenizer for OpenAI, let's say GPT-4o models. So every word or every character that goes into the model, the foundation model, that goes as a token. So you can see hello is one token, space and how is one token, space and r is one token. So correspondingly, the sentence that we are giving, that is first tokenized, and then these tokens are fed into the model, and the uncommon words that the model is seeing, so what it does, it breaks it down into multiple tokens. So that tokenization actually broke down into token and ization. Because ization it would seen a lot of times, and token it would have seen a lot of times. So that's why tokenization is broken down into two tokens. Then space and the quotes is one token, simply quotes is another token. So this is how there is a another algorithm like BPE and other algorithms that these models are using to actually convert these sentences into token. But for us to understand, I think it will be easier that as a rule of thumb, it's around 4 characters or 3/4 of a word. So 100 tokens is equal to around 75 words. So this is how we can actually estimate our token usage, input and output tokens. And you would see every token is then assigned actually a numerical ID, and then it is fed into the system. So this is how the model knows. One actually stands for one. The model understands one as exclamation, this quotation mark without a space, and with the space and quote, this would be around 392, I suppose. So this is how um, sentences are broken down into tokens. Tokens are converted into token IDs, and because what the models are understanding is numerical data, not the textual data internally. So that's why all this step is being done. Plus, we also need to break down, tokens. Now we can assign a token to all the different characters that we are seeing. We can assign tokens to larger characters. So that is a call which depends on the algorithms that we are seeing. So if we overkill this solution, we make it very granular, then the output response that we are seeing, that would be a bit slower, because the output of the foundation model, that is one token at a time. Okay, so that is what actually delays the output production or the response of the model. So for latency and for the training, both the things, how much compute is being going into training. So all these internals are actually dependent on how we are tokenizing the model. Okay, so with the maximum output tokens, if I have given 2560, that's fine, but if I, let's say, give just 20, and so now what would happen? Hello again. So it would now respond in, try to respond in shorter or just in 20 tokens, but the downside of this is if it's a bigger response and it's not able to downsize it, it would break in between. But yeah, if we want to restrict on output tokens, we don't want the model to go on and on, we can actually do that. So 512 would be also a good output token. Stop sequences, this is very nice, that if I don't want the model to utter something, okay, if I don't want the model to go in certain direction, I can simply ask it, okay, stop whenever you see assist, stop whenever you see any word that I don't want. Okay, let me again ask hello again. Vibhag, if you have any questions or need assist, so see, need assistance with anything or something like that, but it stopped at this token actually. Stop sequences help us do that. If we want to, let's say it's going in certain direction, we want to avoid certain words in our output, or it starts going in that direction. So all that can be actually done using stop sequences. Now these are more knobs, temperature and top P. These are also pretty helpful, but to understand these knobs, we need to first understand the transformer architecture. I won't go into the details, but as you see, this is the entire transformer architecture. Let me just refresh this so that it resets. Okay, so this is the sentence: data visualizations empowers users to. Now after to, there are all these different options as the output. Okay, so this is the vocabulary. So if the vocabulary size of this model was, let's see what's the vocabulary size here. Okay, let's go back, let's see the probabilities. You can see these are all the probabilities. I want to go into the logits calculation. Okay, you can see the vocabulary size is around 1.5 lakh tokens. So this is what's the vocabulary size. So these are the tokens that the model can output or that the model has seen, or for these 150 lakh tokens, the model actually has token IDs present. So it would be only able to predict one of these. So it assigns a probability to all tokens that it has in its vocabulary, and you can see the probability of visualize coming after this is 54%. Probability of create, data visualization empowers users to create, to visualize, to see, to make. So all these options are there. Now depending on the knobs of temperature and top P that we saw there, we can change the creativity of the model. So usually the model has seen that data visualization empowers users to visualize. So visualize is a very common occurrence after this sequence of tokens. So this is the token that it has seen around 62% of the time when it was, the model was trained on the entire corpus of the internet. So you can see that is how actually the model is learning. And create, it has seen less number of times. So if I change the temperature to 0, so it now becomes a very probabilistic model. So what happens that it would not try to be very creative. Whatever it is very confident about, it has seen, it will just try to predict that. But if I change the temperature, so you can see the probabilities changing. So you see that it starts to plateau out the probabilities to the different output tokens that even if it had not seen very widely, like build, data visualization empowers users to build. Okay, it might have not seen that very likely, but it is still a possibility. Similarly, on and on. And if let's say, let's keep temperature to 0.5 or even 0.9 or 1 simply. So temperature can go on from sorry, 0 to 10, but here AWS has restricted us to 1 only. Similarly, top P goes on from 0 to 1, and this is what is available. Now if I have temperature as 1, it has plateaued out certain probability, it is not giving 100% to visualize, and top P tells me that how many candidates, percentage of candidates I have access to or I can predict from. So let's say if I just have 0.1, so it now you can see it gave all the probability to visualize. As it will increase, it will start giving probability to other candidates in top X percentage of the candidates. So you can see it starts increasing the probability, and the possibilities of different words coming in the output or different tokens coming in the output also increases. So this is how we can control. These are the knobs actually to control um, the creativity of the model. If we want the model to be creative, we would give it a higher temperature and a higher P. If we don't want the model to be creative, if we want it to be definite, we would decrease the temperature, we would decrease the P. Okay, so this is how these knobs are present, and these actually help us a lot when we are trying to do different use cases. We'll see those things. Now another feature that we have in this playground is a compare thing, where we can actually in real time compare the output of different models. So let me do Amazon Pro and Amazon Premiere. Okay, again the system prompt, let's for here let's just use them. Maximum tokens looks good, temperature and these things. Let's do an apple to apple comparison. Okay, and this looks okay. Top P, let me just change it to 0.9. Okay, now what I'll do is, hello, oh, there was a stop sequence here, so let me just remove that quickly, and now I think we'll be good to try. Tell me, okay, tell me about Bedrock. See, now both the models are trying to go into their knowledge base or whatever data they have been trained to, and depending on the use case. Now, Premiere is actually for very complex use cases where we have complex stuff to solve, complex queries, while this one is for medium level, you can say, like Opus versus Sonnet that we see in Claude. Okay, and you can see the time also it took. So this took around 37 or whatever milliseconds, and this 119. So this took a bit larger because this is a larger model, and it would also be more wordier, as you would see. So it completed its output in 512 tokens, but it was still going on and on. It was like someone with a PhD, or here you would say someone with 10 PhDs trying to solve your simple question about Bedrock versus someone with one PhD. So obviously this person would know more, and they would try to rant more about Bedrock, this, that, whatever. But yeah, in case of complex queries, you would go to Premiere. In case of simple use cases, you can go to Pro. If your use case is even much simpler, like using LLM as a judge, you might even go to the Nova Lite. So these are more distilled models. So there's a process of distillation that happens to make the model smaller and faster, and suited to different use cases. So yeah, I think we had a very good introduction, and we'll continue this. And there are few more aspects that we haven't covered yet, like prompt caching and all those things, which we will cover as we go on and on. But yeah, thank you.